Now, let's talk about velocity. And in these lectures, we will talk about how velocity relate to rate of change and how is this related to the derivative now. So if you know, velocity is really similar to speed, okay? And then what is the difference between velocity and speed? Velocity, we have positive velocity meaning moving forward, negative velocity meaning moving backward. However, speed is just moving one direction then. Okay, so this is the difference between velocity and speed then. Okay? As you know, speed is equal to distance over time. Okay, so that's why you will have mile per hour, meter per second, something like this, right? Okay. So if you look at a function related to distance and time. Then maybe we call the function, this is the function f here, okay? Then now, you will see that if we look at 2 points, where A and B, x equal to, or maybe time, t equal to A and t equal to B in this case, then. Then now, if we look at the average rate of change, meaning is the slope of this secant line here, okay? Then it will be f of b minus f of a over b minus a. And what is f of b minus f of a? Is the change in the distance. And then what is b minus a? Is a change in time. So this is actually is why speed or velocity is related to the average rate of change now. Okay. Okay, so now let us look at the definitions. Is that right here? The function f that describes the motions is called position functions. So in this case, the function f is a position function then. The average velocity over a time interval between t equal to a and t equal to a plus h will be the change in the position over change in time, which is f of a plus h minus f of a over h. In this case right here, it means that instead of giving you a b, it's actually give you a distance h, right? So this become a plus h now, okay? And of course, to this point right here, it will be f of a plus h the output is f of a plus h, and then the input will be a plus h. Okay? So we have this point right here. And of course, this point will be a f of a. Right? And now, f of a minus h over f of a over a plus h minus a, then you see a and a cancel. So that's why you have h right here then. We also could talk about the average velocity over a time interval AB. Then in this case, it will be f of b minus f of a over b minus a. Okay, this is what we have here. Okay, so now what if we take the limit as h oppose 0 of f of a plus h minus f of a over h? Again, remember this is the slope of the secant line, which is the average velocity, okay? Then in this case, we will be able to get the f prime of a, meaning it will be the instantaneous velocity v of a of the time t equal to a then. Then this is how it is related to the derivative that we have now. And now, if I want to find speed, how do we get a speed from the velocity now? Okay. And then one thing about this is if you find out the velocity, then basically speed is equal to the absolute value of f prime of a. Okay. This is how we find speed now. So now let us work on this example now. Okay. Is that right here, a particle move along a straight line with the equation motions s equal to f of t equal to t to the negative 1 power minus t, where s is measured in meter and t is in second. Then I would like to find the velocity and the speed when t equal to 5. Okay. Then let's see how we work it out the problem. Okay. So first, we would like to set it up. I would like to find v of 5, which is the instantaneous velocity at t equal to 5. So which is f prime of 5, which is equal to the limit h oppose 0 of f of 5 plus h minus f of 5 over h. Then now look at the functions. I have f of t equal to t to the negative 1 minus t. Or I could rewrite this into 1 over t minus t then. Okay. Then remember we have a trick to take care of the input 5 plus h, right? So we could replace it t with a box. It is equal to 1 over the box minus a box then. Okay. Okay. So then now let's see. So now I have f of 5 plus h, which is 1 over 5 plus h minus 5 plus h. Okay. And now we would like to subtract f of 5. So then it will be 1 over 5 minus 5 all over h. Okay. And now let's see if we could simplify some of the expressions. And you will see that negative 5 plus 5, they cancel. Okay. Nothing we could cancel now. Okay. Then now my next step is I would like to find the LCD. So in this case, my LCD will be 5 plus h times 5. Okay. Let's see how we use the LCD to help us to create the fractions and simplify the expression now. Okay. What I will do, or what I need to do, I would like to multiply the expression that I have is with 5 times 5 plus h over 5 times 5 plus h. So meaning I just multiply top and bottom by the LCD. Okay. So if I do this, then I will have, again, it's like this one multiplied to this whole thing, and then this multiplied to this multiplied to this. This is the idea, right? 1 over 5 plus h multiplied to 5 times 5 plus h minus h times 5 plus h minus 1 over 5 times 5 plus h over h times 5 plus h. Okay, so 5 and 5 plus h and 5 plus h cancel, so I have 5 left. Minus 5h 5 plus h minus 5 and 5 cancel. Okay. Let's take care of the parentheses. So I will have this one would be 25h minus 5h squared minus 5 minus 5h. My bad. It should be minus 5 minus h. Okay. And I have 5h 5 plus h. Okay. So five minus 5, you can cancel it. So negative 25h minus h, negative 26h minus 5h squared by 5h times 5 plus h. So we could take out the h. And now h and h cancel. Then direct substitutions, we will get negative 26 divided by 5 times 5, which is 25. So velocity is equal to negative 26 over 25 meter per second, and speed equal to 26 divided by 25 meter per second. Okay, thank you.